Greetings everyone, today we will in second chapter basic mathematics. This will be the third lecture of this series. Second chapter basic mathematics, lecture number 3. So in this lecture, students, basically we will discuss coordinate geometry and its relation with physics. Basic geometry, basic coordinate geometry. So basic coordinate geometry actually says that our world is actually three-dimensional space, 3D space, where x happens to be one axis, y happens to be another, and z or z happens to be the third axis. This makes our world as 3D world or 3D space. This happens to be origin, and this is minus y, and this is minus x. Okay, students. Yes. So the x happens to be xy happens to be in a plane, and z happens to be in the space, into the space. So it is going towards you. So we note we have origin O and 3 axes such that two axes are always in a plane, are always in a plane while the third in space, making 3D world possible, making 3D, D here means dimensional, world possible. So you can take any axis y, z or x, z as a plane and consider y or any other axis as third axis or into the space. I have taken z into here into the account. So the next part, that how actually coordinates geometry deals with physics and what its application are. Position of a point in coordinate geometry. So I will write till here. First, consider in a plane. In a plane, we can take xy plane, yes, xy plane. So the coordinates are what, students? X and y. So the coordinates become x, y, x comma y. Example. So this is how you write in physics the coordinates. Example. We have two axes, x and y, and 1, 2, 1, 2, minus 1, minus 2, minus 1, minus 2. So this happens to be minus y, of course, this happens to be minus x, and this happens to be origin. So the thing is, consider a point here, reference point. So this is 2 minus 1. So this is how you would write x and y coordinates. In a space, how would you write the coordinates? So very easy. We'll just increase another comma. Yes, very nice. Another coordinate. Coordinates become x, y, and z. So you always do in this manner to increase the coordinates. For now, the discussion moves to distance. So how distance is being measured into the coordinate system. From now, we discuss 2D system. 2D system, and that too the distance. Yes, very good. So what is distance formula, students? Distance formula: x1, y1, and x2 and y2. So these are actually, this is final point here, students. x2, y2. This is the initial point I am taking in our reference system. Then distance formula should be, so if you would know, we would be a mathematician, but d under root x2 minus x1 whole square y2 minus y1 whole square. Yes, this is how you would measure distance in coordinate geometry. Any distance basically of a straight line. So this gives the distance between the 2 points in a plane. So the next part, midpoint. Yes, this is first point of the theory. First point. Second point, midpoint. Midpoint of what, students? Of a line. Of a line. Of a line. So you have a line such that x1, y1 and x2, y2. So what would be the midpoint? So x1, x2 upon 2, and this happens to be y1 plus y2 upon 2. So this gives, yes, the midpoint of a line. Very nice, students. Slope of a line. Slope of a line. Slope of a line. 2 points. 2 points A, x1, y1 and B, x2, y2. So these are the 2 points, students, of a line, and we will measure the slope now using these 2 points. You think of yourself now, what could be the formula of slope? So slope formula is m happens to be y2 minus y1, x2 minus x1. Yes, very nice. So you would say, sir, we didn't understood a thing. You wrote a formula, you wrote points. How would you represent? So you draw the graph. Draw the graph, students. So I am taking y1 here. Okay. So this happens to be, yes, initial point. This happens to be what, students? Final point, and it is here. This happens to be, yes, x1. Very nice. And this happens to be x2 of this graph. Then certainly the slope actually becomes something like this. This is basically the slope of the graph. This is theta. Actually, this is not angle. This is not slope. This is angle of the graph. This is B, and this happens to be the A point. So x2, y2, x1, yes, students, y1. So this is the slope, actually tan theta. Yes, sir, you have not written tan theta. So slope is equal to m tan theta upon y2 minus y1 x2 minus x1. Yes, that is correct. So the next part, so the thing here to be discussed is straight line equations, students. Straight line equations. That how straight line equations are being used. straight line equations. Straight line equations. So first, the general form I want to discuss. General form. What is the general form of a line? Yes, ax plus by plus c is the general line of an equation. Okay, students. This is the general equation where a, b, c are constants. Yes, very important. Constant. And this, of course, the coordinates. And then, second, equation of x-axis should be what, students? So y equal to 0 becomes the x-axis equation. Yes, very nice. That is actually correct. Okay, good. Now for y-axis equation, so the same thing, x becomes 0. So the basic thing is that logic has to be applied into our framework so that physical nature can be satisfied. Third, equation of y-axis happens to be, yes, x is equal to 0. Fourth point, yes. When x happens to be a and y is what, students? 0. The equation of line, not the equation, the graph of the line. Yes, the graph of the line should be what, students? Yes, this is the a distance and this is actually the graph of x is equal to a and y is equal to 0. So you are traveling x into the coordinate system, x coordinate, a distance into the x coordinate. Okay, students, a distance into the x coordinate and y is taking any value whatsoever. So you are traveling 0 distance into the y but a distance into the x. Suppose y, now suppose y happens to be a and x happens to be 0, then what you will do? Fifth, when y happens to be a, yes, and y happens to be a and x happens to be 0. Yes, sir, students. Yes, sir. Maybe, sir, you should not take it as A, you should take it as B. The x happens to be 0. Then this happens to be B and this happens to be y and this is actually, yes, the B distance B coordinate and B distance along the y. Okay. Yes, you are right. First I should write y coordinate. So this is x coordinate should be here and y should be here. 6 point line equation with slope. Line equation with slope. With slope. So now you would be dealing with line equation and so with the slope. Now you would say, sir, we have already dealt with it. Yes, you have, but not so much into our account. So line equation is actually says y mx plus c. This is the line equation, general line equation for y coordinate. For every y coordinate, x remains a coordinate, and m happens to be its slope, and c is intercept or constant along the y. So I would write also dy by dx or differentiation of y with x gives m. We will discuss differentiation later, but for now this happens to be tan theta, where c is what is intercept. Yes, very nice. Intercept or constant along what? Along y-axis, or constant on y-axis. I should write here intercept on y-axis, y-axis, and this is our constant on y-axis. M happens to be, yes, slope of graph, slope or gradient of graph. This is another name of slope. Representation in a graph. How would you represent this equation into the graph? Representation in a graph. So we have y, we have x. This is theta, and this is the slope. Then what should be the intercept, students? C. C is 0 here, students. Okay. So constant here becomes 0. Here, first part, here C happens to be 0. This implies what, students? Y is equal to mx. Okay, so this is origin. Okay, now the next part. What is the next part, sir? Next part actually says that C is some value. So you can take any value, positive or negative, your wish. I am taking positive for now. So C happens to be here. C intercept. Yes, the coordinate. C happens to be here, students. And this is the slope. This is the slope. And this is actually x-axis. This is y-axis. Right. So what equation? Wow, the equation is repeating here itself. Y mx plus c. So, but I would write so this thing is actually this thing in equation could be written y is equal to mx plus c. The next part, and c, yes, c happens not equal to 0. So this is the equation, and c not equal to 0. C not equal to 0, this equation becomes satisfied. Second part. Seventh, when the line equation is such that x upon a, y upon b equal to 1. So you would be saying, sir, you have written an equation, but what good it does? So is a line. It is actually a line equation, student. A line intercept form, not equation. I don't need to. Line intercept form where A and B are what? Intercepts. Very good. Where A and B are intercepts. They are intercepts on x and y respectively. Axes respectively. Okay, students. How would you draw it into the graph? By hand. So the thing here to be so the graph becomes y and x, and this is actually yes b, and this is a into the x. This is actually graph. Okay, students. So this is the x and y, x upon a plus y upon b form equal to 1. Okay. 8th point. The slope, yes. The slope of line, ax plus by equal to 0, then you tell me for now what would be the slope. So slope should be minus coefficient of x upon coefficient of y. Coefficient of y. And what are the coefficients here? So minus a upon b. Yes. So this was the basic trigonometry, basic coordinate geometry part. I will stop here. Thank you.